At the heart of inheritance lies the shared responsibility model, which all major cloud providers implement but interpret differently. AWS defines the line between security of the cloud, handled by Amazon, and security in the cloud, handled by the customer. Azure uses similar terminology, but emphasizes the concept of shared implementation, reflecting its hybrid enterprise heritage. GCP frames its model around the principle of layered defense and collaboration between platform and user. For example, encryption at rest may be managed by the provider by default, while network configuration or identity assignment remains with the customer. Recognizing these distinctions prevents misunderstanding during R2 scoping. Mature programs document not only what is inherited, but also how each provider articulates its boundary of care. Identity foundations differ structurally across clouds, yet all serve the same function, defining who can act within each environment. AWS uses accounts organized under organizations. Azure relies on subscriptions within tenants. GCP structures resources within projects under folders. Each framework enforces hierarchical ownership that impacts billing, access, and isolation. For instance, an AWS account boundary separates environments more rigidly than an Azure subscription, which may share a common identity directory. Mapping these foundations clarifies how administrative privileges and segmentation interact. In R2, understanding identity hierarchy supports correct inheritance mapping because control over identity affects nearly every other safeguard in the cloud landscape. Authentication through single sign-on, or SSO, and federation patterns ensures that human users and service accounts authenticate consistently across environments. Each provider supports identity federation to external directories such as Azure Active Directory or third-party identity providers. AWS integrates through SAML or OIDC connections to manage console and API access, while GCP supports similar methods through cloud identity. Multi-factor authentication policies, conditional access, and just-in-time provisioning help maintain parity. For example, enforcing mandatory multi-factor login for administrative accounts in all clouds avoids weak links. Inheritance documentation must show which authentication mechanisms belong to the provider and which the customer configures. Uniform authentication models simplify audits and strengthen security posture simultaneously. Authorization models vary in terminology, but share the principle of least privilege. AWS employs Identity and Access Management, or IAM, with roles, groups, and policy documents. Azure uses Role-Based Access Control, or RBAC, tied to resource scopes, and GCP applies IAM roles and permissions attached to projects. Each model defines what users or services can perform and at what level of granularity. For example, GCP's custom roles allow precise permission sets comparable to AWS's managed policies. The challenge is translating equivalent privileges across platforms to maintain consistent governance. R2 practitioners often create crosswalk tables, mapping roles and permissions between clouds, ensuring that inherited authorization practices yield equivalent assurance outcomes regardless of provider. Logging and audit services form the backbone of transparency in cloud environments. AWS CloudTrail, Azure Activity Logs, and GCP Audit Logs capture configuration changes and access events across accounts or projects. While functionally similar, their default retention periods, export options, and integration methods differ. For example, Azure automatically routes diagnostic logs to log analytics, while CloudTrail requires explicit storage configuration. Auditors expect evidence that logs are centralized, retained according to policy, and protected from alteration. Bridging gaps between platforms often involves exporting all logs to a unified monitoring system. Establishing parity across logging services demonstrates that multi-cloud visibility is intentional and consistent, not accidental or uneven. Encryption services across clouds provide multiple key management options, each with nuances. AWS Key Management Service, Azure Key Vault, and GCP Cloud KMS all support provider-managed and customer-managed keys. Providers automatically encrypt most stored data, but customers often assume responsibility for managing key life cycles, access policies, and rotation intervals. For example, enabling automatic key rotation every 12 months aligns with common compliance expectations. Some organizations extend control further with bring your own key or hold your own key models. R2 assessments require clarity about which encryption responsibilities are inherited and which are enforced by the customer, ensuring cryptographic governance remains continuous across providers. Networking primitives also differ but serve equivalent purposes for segmentation and control. AWS uses virtual private clouds, subnets, and security groups. Azure implements virtual networks and network security groups. GCP uses virtual private cloud networks and firewall rules applied globally. Each supports isolation, routing control, and peering. The main difference lies in configuration philosophy. AWS favors explicit constructs, while Azure and GCP integrate more directly with identity and policy layers. For instance, isolating production workloads requires identical segmentation logic across all platforms, even if implemented differently. Documentation of network topology and firewall rules across clouds provides the evidence assessors need to confirm that segmentation intent is consistent, complete, and well understood. Monitoring, alerts, and service health tools, such as AWS CloudWatch, Azure Monitor, and GCP Operations Suite, offer telemetry and alerting capabilities to maintain operational visibility. Each platform provides metrics, dashboards, and automated alert pipelines. The key is ensuring equivalent coverage across providers so that alerts trigger with consistent sensitivity. For instance, latency thresholds in AWS should align with those in Azure to avoid blind spots. R2 validation checks that monitoring configurations are documented, tested, and reviewed. Providers supply underlying health metrics as inherited evidence, while customers must demonstrate their own event management and escalation processes. Together, these layers confirm that monitoring transcends platform boundaries. The line between provider inheritables and customer responsibilities must be defined precisely. Providers handle the physical infrastructure, hardware security, and foundational services, while customers manage data, access, and configuration. In multi-cloud models, this delineation must be documented individually for each platform, because even similar services differ in operational detail. For example, serverless platforms may include automatic patching under provider responsibility in one cloud, but require explicit configuration in another. Maintaining clarity in these distinctions ensures no control gaps exist. The strength of inheritance lies not in convenience, but in disciplined transparency about who protects what and how that protection is validated. Documenting inheritance decisions is a formal process, not an afterthought. Organizations must create matrices showing each inherited control, the provider's source evidence, such as SOC2 or ISO 27001 reports, and the residual responsibilities retained by the customer. Limits of inheritance should be clearly stated. For example, encryption may be inherited only for managed storage services, but not for data transferred externally. These records should include version references and validation dates. Well-documented inheritance frameworks streamline R2 assessments by giving auditors clear paths from control to proof. They also help internal teams manage risk consistently as cloud services evolve. Evidence mapping across providers connects inherited assurances to customer-implemented controls. Cross-mapping tables show how provider attestations align with R2 requirements and where supplemental evidence fills gaps. For instance, an AWS SOC report may cover data center security, but the customer must still provide monitoring evidence for application-level logging. Aligning these mappings across clouds allows organizations to maintain a unified assurance story. During R2 assessments, evidence mapping demonstrates maturity by proving that the organization understands not only what controls exist, but also how they interlock across platforms to form a complete defense-in-depth narrative. A consistent, defensible inheritance approach transforms multi-cloud complexity into structured assurance. R2's value lies in helping organizations articulate their shared responsibility boundaries and verify inherited safeguards with precision. Whether operating in AWS, Azure, GCP, or all three, the same principles apply: clarity, documentation, and evidence. By maintaining parity across identity, encryption, logging, and monitoring, enterprises can scale safely without reinventing governance for each platform. In the end, inheritance is less about delegation and more about partnership, a collaboration between provider reliability and customer diligence that ensures resilience, transparency, and trust across the entire cloud ecosystem.